I'm going to cover the use of state in the Flet application that we're building, which is a game. So we're importing Flet as ft. So this ft is Flet. The useState is for managing the component state with the useState hook. So in the code, we use the state here, just like React, useState. So this underscore is a variable. We don't have a setter. We're not using a setter in this. So this ft useState, and it's holding the game state, which is a Python class. So the useState, it has the current state and a setter function, which we're not using. It's similar to React's useState hook. The way we use it is that our game state, it has a function called change direction here. If we look at our game state, there's a function here for change set direction. And whenever the state changes, the component, which is the girl, will re-render. The state will persist between re-renders, so all the values of the state are going to be held at the last variables in it. Only the component that is using the useState will re-render. So this is kind of good for the screen so that you're not redrawing the entire screen every time. Second return value, the setter, is optional. We're not using it. So we just have the underscore for the setter. We don't use it. We manipulate the state object directly. Typically, you have the name, so you can call this anything. And then you have the setter, which is the way to set the state of it. If you do use a setter from ft useState, right? So this is the setter here. You just pass it the new value. And the value could also include the count. In many applications, you would use a setter for integer, strings, and tuple. In our case, we have a mutable object because we use the ft.observable decorator on our class. So anything within that class will trigger the re-render of the screen. In our example here, we can mutate or change the state directly. So we can just simply change the location of the girl, Pepper, directly on the state. Again, we're using the observable class, and this is what makes it happen. We have the keyword ft.observable here. And so when we change something like the sprite y or the sprite x here, anything that's using it will re-render. If you don't use the observable, you would use the setter here. Without the observable, the types that you have with the useState are immutable. You can't modify them directly. So you have to use this setter to set the value of the state. You can break up the state in different ways. So there could be another thing for count or is paused that you just want to change this and only change a portion of the screen. So you can have a fair bit of control over how you want the screen to re-render. If your variables, the things that you're tracking, they're unrelated, use useState and separate calls with the setter. If it's all related, in our case, it relates to primarily the sprite component, then you can use an observable class, which is what we're doing. Right now, you probably just want to get the girl to move on the screen. However, this state, there's different ways to do it, and it may work for a simpler application, but if you want to optimize it, you don't want to set the useState right here. If it has heavier computation, you want to put it on a separate function and then use a lambda, which is very similar to an anonymous function, which you might be familiar with from JavaScript or TypeScript. or dark. So this is a ft component. So in a Flet component, because it's re-rendering, if you have the logic, for example, to increment it by 1 within the component, it's going to create an infinite loop where it's going to continue to re-render and update the state, which will then cause another render. The component will re-render when the state changes, but the re-render, in this case, modifies the state again, and it creates an infinite loop. So if there's x and y coordinates, and you have a dictionary here, that's the state. You probably want to put this in an observable. The problem is going to occur if you just change the x value here. And this thing won't re-render because you have to change the entire dictionary. What we're doing in our example is we are using the observable. So the x and y positions, if any of these are changed, then it will re-render. So for the useState, we should use observable classes for complex state. So in ours, we have the direction, the sprite, the current frame, and all of these are connected to the movement of the girl. So any change to any one of these, we want the girl Pepper to be updated or re-rendered on the screen because her position is going to change, or this will be related to the animation frame, right? And without a change to the screen, you won't be able to see the next frame of the animation. If you just have one primitive type, you should use the setter and not use the observable class. If the computation is heavy or expensive at the time of initialization, you should pass it a function and don't modify the state during the render. So don't put the state change within the component itself because you'll create an infinite loop. Keep the state local and minimize it unless you need to share it. We also use the Flet use effect, which runs the code when a component mounts or when the dependencies change. And we're using it for animations. Our game, we're using the useState, and we're passing it the function start animation, and we're not passing it any additional properties. You can control how the screen is re-rendered. So ours is blank, which tells it to run the setup here with the name of the function once at time of mount of the component. You could also have it run every time count changes, for example. Include the dependencies if the effect uses it. We use an empty array in our example for one-time setup. And cleanups the use effect does have cleanups. It has many other features to it, using multiple effects, running the effects conditionally. But we're going to cover this in the future in more detail. Right now, we're going to get back to the code and get the girl moving with animation.